Hello friends, let us solve some examples of definite integration. See, the value of integration 0 to pi e to the power cos square x cos cube to n plus 1 x dx. The value of this integration, and n is in z, is say 0, pi, 2 pi, to n plus 1. Now see, in definite integration, in good set or even in JEE, try if some properties is being used here. So here there is one property that we know, that integration 0 to 2a f of x dx equal to 0 when, so if f of 2a minus x equal to minus fx. So this is a property here that we can use here, and see, in this example our fx is e power cos square x cos cube to n plus 1 x, and 2a is pi here. So f of 2a minus x, so let us take 2a is pi, so f of 2a minus x, that means f of pi minus x, so e power cos square pi minus x cos cube 2n plus 1 pi minus x. Now cos pi minus x, so that is in second quadrant, and second quadrant cos is negative, but here you can see that this is square, so it remains as it is, so e power cos square x. Now 2n plus 1 is odd, so odd times pi minus x, so it is like this, cos cube 2n plus 1 pi minus 2n plus 1 x. So 2n plus 1 pi is again in second quadrant, and it is cosine is negative and cube is there, so we are having like this, it is minus e power cosine square x cosine cube 2n plus 1 x. So f of 2a minus x, this is minus fx, and so the value of integration is 0. Okay. Take one more example. Integration 0 to pi by 2 cosine power phi x by 2 into sin x dx equal to blank. Options are 2 by 7, 1 minus 1 upon 8 root 2, then minus 4 by 7, 1 minus 1 upon 8 root 2. 4 by 7 1 minus 1 upon 8 root 2 and 0. Now this is integration 0 to pi by 2 cosine power phi x by 2. Now this sin x, this we can write as 2 sin x by 2 cosine x by 2 dx. And so this we can have like 0 to pi by 2 cosine power 6 x by 2 sin x by 2 dx, and 2 is here. Now we can very well know that the sine and cosine are the differentiation of each other. So here again we use the formula that fx power n into f dash x dx equal to fx power n plus 1 upon n plus 1. Now what is fx here? Cosine x by 2. And what is its derivative? F dash x 1 by minus 1 by 2 sin x by 2. So we try to write in that format, and that is nothing but integration 0 to pi by 2 cosine power 6 x by 2, and we write like its derivative minus 1 by 2 sin x by 2 dx, and make it balance. So we have multiplied with minus 1 by 2. So can you write like this? It is minus 4. So that will be the same one. Divide by 2, multiply by 2, negative sign also. So now this is exactly in that form. So then we can now solve that this is cosine power 7 x by 2 upon 7, and that is 0 to pi by 2. So this is minus 4 by 7. Now cosine power 7 x is pi by 2. So pi by 2 and divide by 2. So it is pi by 4 minus cosine power 7 0. Cosine 0 is 1. So that is minus 4 by 7 cosine power 7 pi by 4. So cosine pi by 4 is 1 by root 2. And its power 7. So it is 1 by root 2 power 7 minus 1, and root 2 power 7. So that is nothing but root 2 power 6 into root 2. So that is 8 root 2. So this is nothing but 4 by 7 1 minus 1 upon 8 root 2. So the option C is the answer. Take one more example. Integration 1 by 2 to 2 1 over x cosec power 101 x minus 1 over x dx equal to blank. Options are 1 by 4, 1, 0, 1, 0, 1 by 2. Now here, so we write this as I, and what we do here is we take 1 over x is equal to t, say, and therefore x is equal to 1 by t. Dx is minus 1 by t square dt. What about limits? So when x is equal to 1 by 2, t is 2, and when x is 2, t is 1 by 2. So this integration I becomes 1 by 2 to 2. So 1 by 2, then this is 2, 2, so then it is 1 by 2. 1 by x is t, cosec power 101, x is 1 by t, 1 by x is t, and dx is minus 1 upon t square dt. Now this is equal to, let us use minus sign to revert this integration limits. So that is 1 by 2 to 2, then 1 upon t square and t, so that is 1 by t. This is, can I write cosec power 101 and take minus sign outside, so that is minus of t minus 1 upon t, and cosec of minus is minus cosec, so that is, and power is odd, so minus cosec power 101 t minus 1 upon t dt. Now see, this I is 1 by 2 to 2, 1 by x cosec power 101 x minus 1 upon x. So it is also same. So this is nothing but minus I. So therefore 2I equal to 0, and therefore I equal to 0. So answer is 0. Let us take one. Integration 0 to pi by 4 sin square x cos square x over sin cube x plus cos cube x and its square dx is equal to blank. Options are 1 by 6, 1 by 12, 1 by 4 and pi by 8. So here again you can see this example, it is not difficult. What you can do here is integration 0 to pi by 4, this divide by cos cube x, so that that will be 10 cube, and cosine power 6. So it is like this, sin square x cos square x. So we take cos cube x outside, power 2, so this is cosine power 6x. This is sin cube x over cos cube x plus 1 square dx. This let us simplify, 0 to pi by 4, use this cos cube x, cos power 6 cos square, so that is cos power 4. So here it will be cosine power 4. Now use that sin square over cosine square, so that is 10 square x, and one more cosine square x, 1 upon cosine square x. So it is like this, sin square x over cosine square x, 1 over cosine square x, so that is a sec square x, and this will be 1 plus 10 cube x and its square. Okay, and now this is easy, so you can take again the same kind of formula that we are having. We can say this is a like 0 to pi by 4, 1 plus 10 cube x power minus 2, and this is 10 square x square x. What is the derivative of 1 plus 10 cube x? And that is nothing but 3 10 square x, and derivative of 10x is sec square x. So we multiply 3 and we divide by 3. So this is our fx, power n is minus 2, and this is our f dash x. So this is equal to 1 by 3, 1 plus 10 cube x power minus 2 plus 1 over minus 2 plus 1 and 0 to pi by 4. So this is minus 1, so minus 1 by 3, and again this is 1 plus 10 cube power minus 1, so it is 1 upon 1 plus 10 cube x, and that is 0 to pi by 4. So minus 1 by 3, if you put pi by 4, then 10 pi by 4 is 1, so that is 1 over 2, and when you put 0, then 10 0 is 0, so that is 1. So this is minus 1 by 2 and minus 1 by 3, so answer is 1 by 6. So A option is the answer. Let us take one more example. Integration pi by 2 to pi e to the power x 1 minus sin x over 1 minus cosine x dx is equal to blank. Options are e power minus pi by 2, e power pi by 4, e power pi by 2, and 0. So whenever we are having like e power x, so we should try for the formula e power x fx into f dash x kind of things, and that we know e power x fx plus f dash x is e power x fx. So let us now solve this example. So this is pi by 2 to pi e power x. Now see, can we write 1 minus sin x? So 1 minus sin 2x formula, 2 sin x by 2 cosine x by 2, and 1 minus cosine x, so it is 2 sin square x by 2. So here we are using sin 2x, 2 sin x cosine x. So sin x is 2 sin x by 2 cosine x by 2, and cosine 2x is 1 minus 2 sin square x. So sin square x is 1 minus cosine 2x by 2, or you can say sin square x is 1 minus cosine 2x by 2. So this is equal to pi by 2 to pi e power x. Now see, can I write 1 by 2 cos x square x by 2, and this is 2 cancel, 1 sin x by 2, So this is nothing but cot x by 2. Okay. Now what is the derivative of cot x by 2? So derivative of cot is minus cos x square. And 1 by 2. So this is nothing but integration pi by 2 to pi e power x I can write minus sign outside like this, and cot x by 2, then plus minus 1 by 2 cos x square x by 2. So this is nothing but derivative of cot x by 2. So f(x) plus f dash x. So the integration is minus e power x cot x by 2, and the limits are pi by 2 to pi. So if we take the pi, then this is e power pi cot pi by 2, then minus e power pi by 2 cot pi by 4. Now what is cot pi by 2? 0. Cot pi by 4, 1. So the answer is, this is minus minus plus e to the power pi by 2. So that is the answer, and C option is there. Let us take one more example. Integration pi by 6 to pi by 3 root sin x over root sin x plus root cosine x dx is blank. Options are pi by 4, pi by 6, pi by 12, and say 0. Now we know, again there is one property, even just by looking to this example we can able to solve it. What is the property? The property is integration a to b f(x) dx equal to, if this integration is of this format, integration a to b f(x) over f of x plus f of a plus b minus x dx. See, our if integrand is like this, then the answer is b minus a by 2. So see, in this example f(x) is root sin x and f of a plus b minus x, so pi by 6 plus pi by 3, so pi by 2 minus x, so root sin x, root sin pi by 2 minus x is root cos x. So exactly in this form, so answer is pi by 3 minus pi by 6 by 2, and so that is nothing but pi by 12. So that is the answer, pi by 12 here. Take one more example. Integration 0 to 2a root of 2ax minus x square dx. So, options are pi a square, pi square by 4, pi square by 2 and a. Now, this is again easy example. Just we need to convert into standard format. That formula also we know. So, this can be written like this: integration 0 to 2a. Can I write in this way? And if you have some practice, you can easily do it. Like a square minus a square minus 2ax plus x square. See, that is in the standard form. Now, this is 0 to 2a root of a square minus a minus x square dx, and this is exactly standard formula, root of a square minus x square. So, that integration is, what is the formula? You just recall that formula and you will get the answer as minus a minus x by 2 root of a square minus a minus x square, then minus a square by 2 sine inverse a minus x by 2. So, sine inverse a minus x by a, sorry, and that is 0 to 2a. And see, this will be 0 even when we put 2a here, or when we put 0 here, this whole part is 0 in upper as well as in lower limit. And here we are having minus a square by 2, this sine inverse a minus 2a by a, and plus sine inverse a minus 0 by a. So, this is equal to minus a square by 2 sine inverse minus 1 plus sine inverse 1. Let us see again. Sine inverse a minus 2a, so by a, and sine inverse a minus 0 by a. So, this is sine inverse 1, sine inverse minus 1 okay, sorry, because we have taken minus sign outside. So, here we should have minus sign. Upper limit sine inverse a minus 2a by a, and minus, only in this we need to put the value, and minus sine inverse a minus 0 by a. So, this is minus sign. So, this is minus sign. See, otherwise there will be a mistake. Sine inverse minus 1 and plus sine inverse 1, it will become 0. The answer is not 0. So, do take care. So, this is equal to minus a square by 2, and this is minus sine inverse 1 minus sine inverse 1. So this is minus a square by 2 minus 2 times sine inverse 1. So these 2 cancel, minus minus plus a square, and sine inverse 1 is pi by 2. So the answer is pi square by 2. Let us take one more example. Okay, let us take one more example. Integration 0 to pi x over a square cos square x plus b square sin square x dx equal to blank. Options are pi square by ab, pi square by 2ab, pi square by 4ab, pi square by 8ab. So let us solve this example. Now see here, we are using the property that integration 0 to a fx dx is same as integration 0 to a f of a minus x dx. So here we are using that property, integration 0 to pi, then pi minus x dx over a square cosine square pi minus x plus b square sin square pi minus x. So this is I and this is like this, and we know cosine pi minus x minus cosine x, but it's square, so that will remain same. For similarly for sin square, so this is equal to integration 0 to pi minus x dx over a square cosine square x plus b square sin square x. And so can you easily now say like pi integration 0 to pi dx over a square cosine square x plus b square sin square x minus I, okay, because minus x upon a square cos square x plus b square sin square x, and that is exactly same as I. So this is I, you can take it on this side, so that will be 2I equal to pi integration 0 to pi. Simultaneously we do like this, we divide by cosine square x, so it is sec square x dx over a square plus b square tan square x, and therefore I is equal to pi by 2, and this is can you write this way now, that 0 to pi and like derivative of tan x is sec square x, so you can take that derivative like tan x is equal to say t. And one more thing we need to take care here, 0 to pi, so we should make it 2 times 0 to pi by 2. Otherwise, if I take the tan x equal to t, this integrand the limit of integration tan 0 0, tan pi is also 0. So 2 times 0 to pi by 2 sec square x dx over a square plus b square tan square x. Okay, now we can take tan x is equal to t. So sec square x dx is dt. What about limit? When tan x means when x 0, t 0, x pi by 2, t infinity, because tan pi by 2 infinity. So this is 0 to infinite. Sec square x dx is dt, and this is a square plus b square. Can we take b tan x is equal to t, so that this is t square. Let us try then. So b sec square x dx dt. So sec square x dx is dt by b. Limit won't change. So this is equal to pi by b, and integration is now very simple. 1 upon a tan inverse t by 0 to infinity. So this is pi over ab, and this is tan inverse infinity minus tan inverse 0. So pi over ab, tan inverse infinity pi by 2, and tan inverse 0 is 0. So answer is pi square over 2ab. So B option is there. Take one more example. Integration 0 to 1 log of 1 plus x over 1 plus x square dx is equal to blank. Options are pi by 8, log 2, pi by 8 log 1 by 2, pi by 4 log 2, and 1 by 2. Let us now solve this example. So here you are given log of 1 plus x and 1 plus x square. So can you take x is equal to say tan theta, then dx is sec square theta d theta. What about limits? When x 0, theta 0, when x 1, theta pi by 4. Okay, so this integration I becomes 0 to pi by 4 log of 1 plus tan theta over 1 plus tan square theta, and dx is sec square theta d theta. Now sec square theta is 1 plus tan square theta, so this will be cancelled. So remaining is integration 0 to pi by 4 log of 1 plus tan theta. And now here we are using that integration 0 to a fx dx equal to integration 0 to a f of a minus x dx. So that is integration 0 to pi by 4 log of 1 plus tan pi by 4 minus theta. And so this is equal to integration 0 to pi by 4 log of 1 plus, now this is tan pi by 4 minus tan theta upon 1 plus tan pi by 4 tan theta. So this is equal to integration 0 to pi by 4 log of 1 plus 1 minus tan theta over 1 plus tan theta d theta. Let us take this. So integration 0 to pi by 4 log of 1 plus tan theta plus 1 minus tan theta over 1 plus tan theta d theta, and so this is 0 to pi by 4 log of the tan theta cancel 2 over 1 plus tan theta d theta. Now can you do like this? See, this I is 0 to pi by 4 log of 1 plus tan theta. This is I. Zero to pi by 4 log of 1 plus tan theta. Can you do like this? Integration 0 to pi by 4 log of 2 minus log of 1 plus tan theta d theta. You are using the properties of logarithm, and this is integration 0 to pi by 4 log 2 minus I, and so 2I equal to log 2 integration 0 to pi by 4 d theta. So therefore I equal to log 2 by 2 into pi by 4. So the answer is pi by 8 log 2. So pi by 8 log 2. So that option A is there. Okay, let us solve one more example. Integration 0 to pi sin 2kx over sin x dx equal to blank. K is an integer. Options are pi by 2, pi, 0, 1. So can we do here like using the again the similar kind of result formula 0 to pi f of integration 0 to a f of x dx is equal to integration 0 to a f of a minus x dx. So sin 2 k pi minus x sin pi minus x dx. So this is equal to integration 0 to pi sin 2k pi minus 2kx. Now what is sin pi minus x? Second quadrant sin function is positive. So sin pi minus x is sin x. Now sin 2k pi minus 2x, 2k pi. So it will be here k0, k1, k2, k minus 1 and so on. So it is here sin 2k pi minus 2k pi minus 2 pi x. So it is in the fourth quadrant, and in fourth quadrant sin function is negative. So this is minus sin 2kx over sin x dx, and this is exactly minus I, and therefore 2I equal to 0, and therefore I equal to 0. So option C is the answer. Okay, take one more. Integration 0 to pi x square sin x over 2x minus pi 1 plus cosine square x dx equal to blank. So here options are pi square by 4, pi square by 2, pi square by 6 and 0. So let us solve here. So this is say I, and now again we use the same technique, 0 to pi. This is a pi minus x square sine pi minus x to pi minus x minus pi and 1 plus cosine pi minus x and its square. So that is the result we are using. And now let us see 0 to pi. This is a pi minus x square. So can I write pi square minus 2 pi x plus x square. Sine pi minus x is sine x, and this is a 2 pi minus pi. So this is pi and minus 2x. So pi minus 2x. 1 plus, no change here because cosine pi minus x is minus cosine x, but square is there. So 1 plus cosine square x dx. Now see what is I here, x square sine x 2x minus pi 1 plus cosine square x. Here let us take minus sign outside. So minus 0 to pi square minus 2 pi x sine x plus x square sine x over 2x minus pi 1 plus cosine square x dx. So can you write this way? It is minus integration 0 to pi square minus 2 pi x sine x over 2x minus pi 1 plus cosine square x dx, and again this minus sign here. So minus x square sine x over 2x minus pi 1 plus cosine square x, that's I. So we are having 2i equal to, now here see, you can take pi outside. What it remains? Pi minus 2x, and here you are having, if I consider this minus sign, then pi minus 2x. So that will be cancelled. So remaining is only pi. So pi integration 0 to pi sine x over 1 plus cosine square x dx. Okay, understood? Now this is simple again. If I consider cosine x is equal to say t, then that is easy. So cosine x is equal to t, then minus sine x dx is equal to dt, or you can say sine x dx is equal to minus dt. This is I equal to pi by 2. Let us change the limits of integration. When x 0 t 1 and when x pi t minus 1 cosine pi minus 1. So 0 then 1, t pi then minus 1, sine x dx is minus dt. This is 1 plus t square. and we can use this minus sign to change the integration ends. Minus 1 to 1 dt over 1 plus t square. Again this is even function. You can write pi by 2 times 0 to 1 dt over 1 plus t square. So this is pi, this is standard tan inverse t 0 to 1 pi, this is tan inverse 1 minus tan inverse 0. So this is a pi by 4 minus 0. So answer is pi square by 4. So pi square by 4, here A option. So here A option. Thank you so much.